Example 1 is an example of a question where we want to find the values of the derivative given the graph of a function. So here we've been given the graph of a function. We want to find the values of the derivative of that function from the graph. The first derivative we want to find is f prime of 0. This 0 here tells us that the x-coordinate of the point we're talking about is 0. When x is 0, we're dealing with this point here. At that point here, we want to draw a tangent line and find its slope. The tangent line looks approximately like this. If we want to find its slope, we want to measure the rise and the run of that line. The rise is about twice as big as the run, so this derivative is approximately 2. Note that if you draw the tangent line slightly differently, you might have gotten a value of 1.5 or 3, something around that for this derivative. It's okay with these sorts of functions if you're off by a little bit. The values are not exactly precise. We want to take the derivative at 1. We want to draw a tangent line here when x is 1. That tangent line is horizontal, so f prime of 1 is going to be approximately 0. A horizontal line has slope 0. If we want to find f prime of 2, we want to draw a tangent line at this point here. At that point there's a sharp corner in the graph. If there's a sharp corner, there is no tangent line, so this derivative does not exist. If we want to take f prime of negative 1, we want to draw a tangent line at the point of the graph where x is negative 1. At negative 1, there's a vertical asymptote, which means there's no point on the graph when x is negative 1. In that case, you cannot draw a tangent line, so the derivative does not exist. Note, in any point on the graph where the function is discontinuous, the derivative is never going to exist. The derivative, f prime of x, is itself a function. The derivative depends upon x. Therefore, the derivative itself has a graph. So another type of problem we can deal with when finding derivatives from graphs is to draw the graph of a derivative. If we want to draw the graph of the derivative function, we start with the graph of the original function. We draw the graph by remembering that the y-coordinate of the derivative is the slope of the tangent line to the original function. So to draw the graph of the derivative function, we pick a couple key points on the graph of the function. We draw a tangent line at each of those key points. Then we figure out what the value of the derivative is going to be at each of those key points, sketch a bunch of points on the graph of the derivative, connect the dots to get a graph of the derivative. The most important key points to find are places where the derivative is 0. Basically places where the tangent line is horizontal. A horizontal line has slope 0. At these points, the graph of the derivative function will have a y-coordinate of 0. The graph of the derivative function will cross the x-axis.